Hello guys, in this video we will be discussing about exponential inequality. By its definition, exponential inequality is an inequality in which a variable occurs in an exponent. Now from the word itself, inequality, then we will be dealing with inequality symbols, greater than or equal to, less than, and less than or equal to. Now we have here four properties to be followed in answering our exponential inequality. Now the first property talks about first and second assumptions, such that the first assumption says that if our base, which is a, is greater than 1, meaning to say the base a is an element of any positive number greater than 1, like 2, 3, 4, 5, 6, 7, 8 until positive infinity, even 1.1 is considered as an a value. And our second assumption, if we have here an exponential inequality a to the x less than a to the y, if only they have the same base, which is an element of a positive number greater than 1, then we can actually bring down exponents and we have to copy the sign which is less than. So we have here x less than y. The second property talks about when our base a is greater than 1, and this time we are using greater than symbol, a to the x greater than a to the y, then we have to bring down exponents, so we have x greater than y. Now for letter C, or the third property, if our base a is less than 1 but is greater than 0, meaning to say the a value here is 1/2, 1/3, 3/4, 0.1, 0.4, 0.9. Those are the values. Less than 1 but is greater than 0. And those are uncountable values. And our second assumption, if we have here a to the x greater than a to the y, then if only the base are the same, which is less than 1 but is greater than 0, then all we have to do is to bring down exponents. So we have x, and then the inequality will change into its opposite direction. So from greater than, it will become less than, and then bring down y. The fourth property is actually the opposite of the third property. So we have if our base less than 1 but is greater than 0, and a to the x less than a to the y, then if only they have the same base, provided that the base is less than 1 but is greater than 0, then we are going to use the opposite sign of less than, which is greater, and we have to bring down exponents. Now, the same property holds when we are given with less than or equal to, greater than or equal to, meaning to say less than or equal to, and greater than or equal to are actually the same. So same properties will be used. For example, if we have here 2 to the x greater than or equal to 2. Now, as what you have observed, we are actually using greater than or equal to, meaning to say our greater than is being associated with the equality symbol. Now, what have you observed with the base? The base, both sides are actually the same. Now, the base on the left is actually 2, and the exponent here is x. And the base of the right side is actually 2, and this is understandable that we have an exponent of 1. But it's fine if we will not be writing 1 anymore. Now, based from the property, we are going to solve for x from this exponential inequality. Now, what is our base here? Our base here is 2, meaning to say this is greater than 1. But the given inequality symbol here is greater than. So we have to make use of the second property. Why? Our inequality symbol here is greater than. Now take note, when I say greater than or equal to, the same property will be used. Now why are we using the second property? It's because the base here is 2, which is greater than 1. So the second property holds. Now at this point, according to our assumption, if they have the same base, then all we have to do is to copy the inequality symbol and then bring down exponents. So we have here greater than or equal to, and then we have to bring down exponent. And this is understandable that 2 has an exponent of 1, so we have here x greater than or equal to 1. Now what does it mean? The possible x values that will satisfy from this exponential inequality are the values 1, 2, 3, 4, 5, 6, 7, 8 until positive infinity. So if you will try to write this in an interval figure, this can be written as from 1 to positive infinity. Is 1 included? Yes. Our x here could be 1. So therefore, we will be using bracket. If there is no equality symbol, then we will be using here parentheses, meaning to say one value is not included from the interval. So this is now the answer, x greater than or equal to 1. In its interval figure, we can use 1 to the positive infinity where 1 is included. So these are now the answers. Another example. Assuming we have here 2 to the x less than 4. Now again, our main goal is to solve for x. But before that, see to it that the base, both left and right, should be the same. And this is what we're going to do. Now in terms of the left side, this is 2 to the x. And our right side is actually 4. Now 2 is already in its base form, meaning to say you cannot transform 2 into another exponential figure with a different base. So I am sure that this must be retained. So copy that. So we have here 2 raised to the power of x. You have to copy the inequality. And 4 must be transformed into an exponential figure with a base 2 raised to the power of 2. So we have here 2 raised to the power of 2. It's because 2 squared is just 4. In this case, we are actually satisfying our assumption that the base must be the same in order to equate exponents or bring down exponents. Now what is our base here? This is greater than 1. So we have to base on the first and the second property. But what inequality symbol being used? Less than. So at this point, we have to base on the first property. It's because our base is greater than 1, which is 2, and our inequality symbol is less than. So what is our conclusion? All we have to do is to copy the symbol, which is less than, and then we have to bring down exponent. So we have here x, and then bring down the exponent of 2. At this point, this is now our answer. Now, what is the other way of writing this into an interval figure? This is from 2 to the negative infinity. Is 2 included? No, because there is no equality symbol being associated with. So we have to make use of the parentheses. Meaning to say the possible x values that will satisfy from the given inequality are the values 1.9, 1.8, 1.7, 1, 0, negative 1, negative 2, negative 3, negative 4, until negative infinity. That's why we have here the interval from 2 to the negative infinity where 2 is not included. So you can write this way or the interval figure. Another example, assuming we have here 1 over 5 raised to the power of x plus 3 greater than 25 raised to the power of negative x. Now at this point, we can actually let 1/5 be written as an exponential figure 5 to the negative 1. So if we have here 1 over 5, we know that 5, our denominator, is understandable that it has an exponent of 1. Now if you will try to bring 5 to the 1 to the numerator part, from positive 1 it will become negative 1. So this is now equal to 5 raised to the power of negative 1. This is from one of the laws of exponent. So basically, under exponential inequality, we are still dependent on the laws of exponent, because this one follows from the law of exponent 1 over a to the n. If you have here a to the n, bringing a to the n to the numerator, it will become a to the negative 1. And that's vice versa. If you will try to bring down a to the negative n to the denominator, so it will become 1 over a to the n. The sign of the exponent changes. So 1/5 can be written as 5 raised to the power of negative 1. But wait, there is still an exponent, so we have here x plus 3. And we have to copy greater than symbol. And copying 25 raised to the power of negative x. Now again, we have to make sure that our base are the same. Now 5 is already in its base form. Now 25 can be written as 5 squared. Again, we have to make our base the same. So we have here 5 to the negative 1. But take note that negative 1 will be distributed to every term of the second exponent. Now we are going to multiply exponents because there is a conflict of the exponent in here according to the law of exponent. So if we have a to the n raised to the power of m, this is just equal to a raised to the power of n times m. So we are using this law of exponent from the left side. So negative 1 times x, it will become negative x. Negative 1 times 3, that will become negative 3. And we have to copy the symbol which is greater than. And then 25 can be written as 5 to the negative 5 to the 2. But take note, we have still here negative x. So from here, 2 times negative x, okay, basing with the same law of exponent, so multiplying 2 and negative x, it will become negative 2x. So we can actually write here negative 2x. Now, do we have the same base? Yes. Is our base greater than 1 or less than 1? Greater than 1. But what is the inequality symbol being used? Greater than. So at this point, we have to base on the second property. Why? Our base A is greater than 1, and the inequality symbol being used here is greater than. So we have to base on the second property. According to the second property, we have to copy the sign and then bring down exponents. So continuation over here. So bringing down exponents, we have negative x minus 3, copying the same inequality symbol, and then copying exponent negative 2x. Again, we have to solve for x, so we have to transpose negative 2x to the left and transposing negative 3 to the right. So negative x, copying the remaining, and then from negative 2x it will become plus 2x, greater than, from negative 3 it will become positive 3. Now what is negative x plus 2x? They are actually similar terms, meaning to say we have to subtract. So this will become x greater than 3. So this is now our answer, meaning to say the possible x values that will satisfy from our exponential inequality are the values 3.1, 3.2, 3.3 until 4, 5, 6, 7, 8 until positive infinity. Now how to write this one into interval figure? This is 3 to the positive infinity. Is our 3 included? No. So therefore we are going to make use of the parentheses. This is now our answer. You can write x greater than 3 or 3 to the positive infinity. You can choose between the two. Now, it's possible that from the same problem here, it's possible that our base is not 5 but 1 over 5. How to do that? So let me erase this solution. Now what if we are going to transform the base here into 1 over 5? Is it possible? Yes. And we will try if we will be arriving with the same result. So from here, we can just copy the left side. So we have 1 over 5 raised to the power of x plus 3 greater than 25 to the negative x can be written as 25 to the negative 1 raised to the power of x. Meaning to say, this portion here, 25 to the negative x, is just the same when I say 25 to the negative 1 raised to the power of x. Again, this is from the law of exponent. Negative 1 times x is just negative x. So they are just the same. Now, why am I doing this way? So that I can let 25 to the negative 1 becomes 1 over 25. So, copying the left side. So we have 1 over 5 raised to the power of x plus 3 greater than 1 over 25 to the 1 raised to the power of x. Now again, this is following from the law of exponent, one of the laws of exponent, which says that if you have a to the negative n, that can be written as 1 over a to the n. So from negative exponent, it will become positive. And this is what we did from 25 to the negative 1, which is inside the parentheses. But 25 to the 1 can be written as 25. So it's possible that we can write that as 1 over 25. Now let us continue. Now, copying the left, we have here 1 over 5 raised to the power of x plus 3. Copying the inequality symbol, so 1 over 25, this can be written as 1 over 5 squared to the x. Anyway, 5 squared is just 25. But 1 over 5 squared, this can be written as 1 squared over 5 squared. Again, the inside value, 1 over 5 squared, we actually write that into 1 squared over 5 squared. Anyway, 1 times 1 is still 1 because 1 is a perfect square. Why are we doing this way? Okay. We have to copy the left side. So 1 over 5 raised to the power of x plus 3. Now, why are we doing this way? So that we can actually write that into like this. Let me erase this. So copying the left first. So we have here 1 over 5 raised to the power of x plus 3. Copying the inequality symbol. And then 1 squared over 5 squared can be written as 1 over 5 raised to the power of 2. Okay? What is our basis? One of the laws of exponents, such that if we have a over b raised to the power of n, this can be written as a to the n over b to the n. This is from one of the laws of exponent. And this is what we did from this part. So this is actually possible coming from this law of exponent. But wait, there is still an exponent of x. So we can just write here x. Is our goal being satisfied that the base should be the same? Yes, our base now here is 1/5. But what is the inequality symbol being used? Greater than. Take note, this is actually greater than coming from here. So therefore, we have to make use of property, the third property, which says that if we have here the base less than 1 but greater than 0, and we have the inequality symbol greater than, then all we have to do is to bring down exponents, and take note that from greater than it will become less than. So from greater than it will become less than, and we have to bring down exponents. And then the exponent of the right is 2x. Now we have to transpose x to the right. You can do that. So from the left, what remains is 3, and then copying 2x. So from positive x, it will become negative x. And then continuation here. So copying 3 less than, what is 2x minus x? This is actually x. And if you are going to switch places, this one could be written as x greater than x, meaning to say the mouth is actually opening on x. So if you will try to swap, the mouth is still opening on x if you are going to switch places. So x greater than 3. So what does it mean? This means to say that our possible x value starts from 3 until positive infinity. Is 3 included? No. That's why we are using parentheses. So what are the x values that will satisfy from our exponential inequality? Those are values greater than 3, like 3.1, 3.2, 3.3, until 4, 5, 6, 7, 8, until positive infinity. Do we have the same result? Yes. Thank you for watching.